Good afternoon, one and all present here, respected speaker sir, respected principal madam, my fellow colleagues, our delegates, and my dear students. I hope you are all feeling energized and ready for another enriching experience ahead. Welcoming you all to the day 2 of our National Faculty Development Program on Emerging Trends in Nursing Research, organized by Royal School of Nursing, the Assam Royal Global University, Guwahati. Myself, Pankilakar, and I'm thrilled to be your anchor for today's event. Over the next few hours, we will be enlightened by our esteemed speaker with knowledge designed to enhance our skills, foster collaboration, and inspire innovation in the field of research. Now, without much delay, I would like to introduce you all our today's esteemed speaker, Sir Dr. Hemanta Saitya, Assistant Professor of Assam Agricultural University. Sir did his Bachelor of Science in Statistics from Nagam College, and he did his Master of Science in Statistics from Guwahati University and his PhD from Assam University. Sir has more than 2 books published under his name and more than 15 research publications in both national and international journals. Sir also received an appreciation letter along with a cash award from the Dean FA Assam Agricultural University, Jorhat, for developing the official logo for College of Sericulture, Titavor, Assam Agricultural University, Jorhat. Sir is a visiting fellow under UGC SAP DRS1 in the Department of Commerce, Dibrugarh University, Assam, and also a visiting lecturer in various programs of statistics. Sir also did a project sponsored by Assam Agricultural University on improved spinning type water remover in green tea manufacturing, and another project sponsored by ICAR, New Delhi, on sustainable security of tribal communities of Assam through sericulture-centric promotional activities. I now request Professor Dr. Hemeshwari Bhuya to kindly felicitate Sir. Thank you, sir. Thank you, ma'am. I request sir to kindly open the session now for all. Thank you, sir.
Good afternoon, everyone. So, how are you? Are you feeling sleepy? No? So, as you can understand from my introduction, that actually I am basically a statistician, completed Masters from Guwahati University, BSc from Nagaon College, and did a PhD from Assam University, Silchar. And I work on data mining in sports, especially I am a specialist in data analysis, and my specialization is data mining. But unfortunately, I joined in Agriculture University. I have to work on agriculture, but again, under agriculture, I am especially working on now College of Sericulture, which is a particularly very specific domain who deals with the sericulture. Okay, but still, I have to look after all the agricultural data, that is data analysis part in Agriculture University. So you can think of my variation. I studied in statistics, then did my PhD in sports data analysis, now working in Agriculture University, now works in agriculture data analysis. So you can think of the variation in my career, what I did from graduation to PhD, and then after during my service, what I am doing. Anyway, so this particular session is basically deals with the statistical software. Okay, then I'm going to make you learn about different statistical software. Ma'am told me to give a lecture on 3 different statistical softwares, that is SPSS, Stata, and then Gemovi. Okay, but from 3:30 to 5, within this 1.5 hour, it is very difficult to learn all these three softwares. Okay, only 2 we can cover. So I have decided to cover SPSS and Gemovi, because Gemovi is a free software, so anyone can go and download it freely, and it is based on R software developed in the R platform. But you don't have to write down any code to run this particular software. Simply just clicking on this, you can get the result. So that is the beauty of this particular software. So you don't need any license key here. It is a free software like R, so you can use it for your research purpose. Then SPSS, now a lot of crack versions are available in the market. So you can also use it for data analysis purpose. So I also have a SPSS version 21. Now presently in the market SPSS 29 is available. But I have a crack version of SPSS 21. If you need, you can take it from me. Okay? Then again, MSI ma'am told me to show in the beginning, to show the data analysis part little bit using Microsoft Excel. Because in Microsoft Excel there is a toolpack called data analysis toolpack, using which you can perform lot of statistical analysis. So it is up to you from which software you want to learn the data analysis part. If you told me to start with the Microsoft Excel, then I will start with Microsoft Excel. If you tell me to start with SPSS, then I will start with SPSS. If you tell me to start with Gemovi, then I can start with Gemovi. Okay, I will start with Microsoft Excel, then we will move on to the Gemovi because it is a free software. Okay? Okay. Thank you so much. Then I have to go there because I will operate this particular software from my laptop because it is not installed here. Okay, this is the dataset that I have already shared with you. Probably all of you have got this dataset, right? So this dataset basically deals with these are hypothetical data, and this dataset first column represents the ID number of the patients, then gender, male and female, age of the respondents, then place. The different places I have considered, then rural. More specifically, rural places, urban places, and riverbank. Then SBP, DBP means systolic blood pressure, DBP means diastolic blood pressure, TSC means total serum cholesterol, then weight of the patients, then height, and then BMI, which is body mass index. So this is the basic data set based on which we will learn how to perform different kinds of statistical analysis using this software. Okay. Then first, using data analysis toolpack, if you open Microsoft Excel, actually I want to share my screen. in Microsoft Excel, when you go to the data, so file menu, home menu, then insert. When you click on data, so you will see here one data analysis toolpack. Okay, using this data analysis toolpack, you can perform lot of statistical analysis. But this data analysis toolpack is not available for all of you. When you install Microsoft Excel, so directly it is not available in your computer or laptop. You have to bring it from the repository. So how to bring it? You go to the file menu, then you click on more, then you have to select options. File menu, then more, then you have to click on options, then you click on add-ins. Moment you click on add-ins, so these are the packages, active packages available in my computer. Analysis toolpack, VBA, Euro currency. Okay, these are the toolpack available. Then these are an inactive application. So for the first time, when you click on add-ins, you will see data analysis toolpack under this inactive application add-ins. So what you have to do in that situation, you have to select that particular data analysis toolpack, that means this one, analysis toolpack, then click on go. Select that data analysis toolpack under inactive box and then click on go. Then you will see this pop-up window, add-ins pop-up window. From this add-in pop-up window, now if I deselect this one, analysis toolpack, then it will automatically remove from my Microsoft Excel. But since already I have installed it, so let it be like this. In your case, you have to select that analysis toolpack, then click on OK. It will take some time, maybe 5 minutes or 10 minutes. Microsoft Excel automatically it will install in your computer. Okay. After that, when you click on data analysis, so these are the analysis available. You can see. Start with ANOVA single factor, then ANOVA two factor with replication, ANOVA two factor without replication, covariance, correlation, then descriptive statistics, exponential smoothing, F-test. Lot of statistical analysis are available. Histogram, moving average, regression, t-test, paired sample, t-test for two sample, t-test for two sample, equal and unequal variances, and last one is z-test for two sample means. And Microsoft Excel, this is the only software where z-test is available. Whether you take Jamovi, whether you take SPSS or Stata, whatever it is, z-test is not available. There is a logic. The logic behind is that earlier there was a concept that z-test can be applied only for large sample and t-test for small sample, some sample sizes are less, that means less than 30. But later on, it has been found that every statistical distribution tends to follow normal distribution when sample size become large. So since t-distribution range is also same normal distribution, minus infinity to infinity, range is same for both the statistical test. And for large sample, since for the large sample, t-distribution or t-table also, t-distribution also looks like a normal. Even if you see the t-table, if you open any statistics book, then t-table, you will see degrees of freedom for infinity is 1.96, which is same for z-test. So that's why, so most of the statistical softwares, SPSS, Jamovi, whatever it is, Stata, they believe that since t-test can be applied for both small and large sample, then only one test is sufficient. T-test is sufficient. You can perform the test, t-test for small sample, you can perform the test, t-test for the large sample also. So there is no z-test separately in case of SPSS or Jamovi. But in Microsoft Excel, separately it is given, but only for two sample means not for one sample. Okay, we will start from the descriptive statistics because we know descriptive statistics means that we talked about mean, median, mode, these are measures of central tendencies, right? Mean, median, standard deviation, these are called descriptive statistics of the data. So let us try to see how to calculate. Let us see how to calculate these descriptive statistics using Microsoft Excel data analysis toolpack. So I want to calculate, so these are the variables. Look at these variables. Gender, age, place, SBP, DPP, total serum cholesterol, weight, height, and BMI. Out of all these variables, can you tell me for which variable or what are the variables we can calculate mean, median, mode, and standard deviation? So one variable is gender, then age, place, SBP, DBP, these are the variables. Can you calculate average, mean, median, and mode for gender? Can you calculate descriptive statistics, mean, median, and mode for place? These are categorical variables. For categorical variable, we cannot calculate mean, median, and mode. We can only go for percentage. Proportion or percentage, that is sufficient. Okay? So, for descriptive statistics, we will go by these variables: age, SBP, DBP, total serum cholesterol, weight, height, and BMI. So, from data analysis toolpath, we select descriptive statistics, this one. Then input range. So input range age is somewhere in between gender and place. So I will not select age. What I will do, I will select from SBP to BMI to calculate the descriptive statistics for these variables. So this is the data range. Then group by columns. Our data is in column wise. So by default it is selected, no need to change it. If your data is in row wise, you have to select by rows, group by rows. But here data is in column wise, so group by columns. Now levels in the first row. Why we need to click on levels in the first row? Because in the first row we have a variable in. There is no data in the first row. Like SBP, DBP, ESC, these are the characters, not the numbers. So we have to define properly in the software that first row basically dedicated to the levels. Now output range, select output range. After selecting the output range, you click on this blank rectangular box. Then click here to display your result, any blank cell. And remember, below that blank cell there should not be any writing or anything. It should be blank. All the cells should be blank, because results should be displayed there. Then you have to click on summary statistics. Click on OK. So these are the summary statistics you can see based on your data. So see, for variable SBP, mean is 139.889, standard deviation 2.49, median value is 143, mode 147, then standard deviation 24.86, sample variance 618.263. So these are the values. For each and every variable, you are having the descriptive statistics. So all the descriptive statistics you will get it by this data analysis toolpath. So anything you would like to ask me, any question related to this descriptive statistics? Any question related to descriptive statistics? Okay, online candidates or participants, anyone would like to ask any question? Okay, you can put your question in the message box. There is no question. Okay. Is there any question? Okay, next. So here, out of all these variables, you can see two variables are categorical variable. One is gender, another one is place. Okay, these two variables are categorical variables. So based on these two categorical variables, what kind of analysis we can perform? So gender, we have only two categories, that is male and female. And for place, we have three categories, that is rural, urban and rural. So for gender, to find out the significant difference between any two groups, I'm not talking about any theoretical theory about the statistics, okay? I don't want to discuss it, but otherwise we will not having the sufficient time to complete both the software. So since here we have only two groups, male and female, so we can, any variable, continuous variable you can take. You can take SBP, systolic blood pressure, you can take EBP, diastolic blood pressure, you can take weight, you can take height, you can take BMI, body mass index. Any value, any continuous variable you can take to check the significant difference between male and female. So here, since number of participants or number of patients are large, here we have 100. As you can see, understand that if number of observations are large, then we should go for the Z test. So here we can perform the Z test for two sample mean to find out the significant difference between male and female, because we have here only two groups. So if there are more than two groups, then what kind of analysis we can perform? For two groups, less sample size less than 30, then t-test. Two sample size more than 30, z-test. More than two groups, then we can go for analysis of variance. So here, let us perform z-test for two sample mean. But to perform z-test for two sample mean, we need some information earlier. Look at this. Variable 1 range, variable 2 range, variable 1 variance known, and then variable 2 variance known. So variable 1 and variable 2 variance should know earlier. So here our variable, by looking at this data set, you might feel that here we have a variable, one is gender, then another one is say body mass index. Okay, but you have to recreate your variable to perform the z-test to sample mean. So how to do it? First you select gender, go to the data, then you filter your variables. Okay, from gender column you select only male, then click on OK, so that you can see only the values related to male. All other female values are hidden now. Now let me consider this one, say body mass index. These are male BMI values. Let us do one thing. Let us take another sheet. And then paste all these values here. Male BMI values and then female BMI values. From the next sheet, original sheet, this time let me select female, deselect male, click on OK, so that I can copy all the female BMI values. Now from these two variables, we have to first calculate the variance. Variance, say for 1, variance 1 means, variable 1 means male BMI variable, okay? To calculate the variance, there are two options. One is var.p, another one is var.s. Always go by var.s when you are collecting sample from the population. Because var.s means variance for sample, and VAR.P means variance for population. So don't go for variance for population, you go for variance for sample. So variance for male BMI patient is 11.51, and then variance 2 means female BMI values. It is 13.52. Please note down these two values. So for male BMI variable, variance is 11.51, and for female BMI variable, variance is 13.52. Now let me go to the sheet number 1. Then I will select all the values here. Then go to the data, and then I deselect the filter. Then sheet number 2, where I kept all the male BMI and female BMI values. Then I click on the data. Then again data analysis toolpath. From here I will select Z-test 2 sample means. Z-test for 2 sample means. So variable 1 range is male BMI values. Variable 1 range is male BMI values, and variable 2 range is female BMI values, and hypothesis mean difference is 0. So we consider that there is no difference between male and female BMI values. So hypothesis mean difference is 0, and variable 1 variance known to us, it was 11.51, and variable 2 13.52. And since I select from male BMI and female BMI values, I click on levels, then I click on output range. Let us display the output from here, then click on OK to get the Z-test for 2 sample mean. This is your result. So first row, male BMI values, mean is 26.19, female BMI values, mean is 25.32. Known variance 11.51 and 13.52, which is already we know. Then observations 53 male patients, then 46 female patients. Hypothesis mean difference is 0, and then calculated Z value is 1.206. This is the calculated Z value, and tabulated Z value is 1.96. It is known to us, this one. So here calculated Z value is less than tabulated Z value, or calculated Z is greater than tabulated Z value. So 1.206 is less than 1.96. So that means we accept the null hypothesis. It means that there is no significant difference between male and female with respect to BMI values. They are same. So this way you can perform different statistical analysis for your research. Since here we have only 2 groups, that's why Z-test. So if you want to perform ANOVA, then you can take this variable, place. Here we have 3 groups, riverbank, then urban, rural. So based on this variable, and by taking any particular variable, continuous variable, you can perform ANOVA test. So which variable you want to take? Say I am going to perform ANOVA test. Out of all these continuous variables, which one you would like to take? SVP. Okay. So this time again I select this particular variable, place, go to the data, then click on filter. Then from here I will select first the river bank. Click on OK. So only river bank values are displayed. Then I take all the SDP values. Next, I will select rural, deselect river bank, then click on OK. So next I will select again urban and then deselect rural. Click on OK. Then I will copy this SDP values for urban. So first variable related to river bank, second one related to rural, and third variable is related to urban. So here our intention is to find it out the significant difference among these three places. So the variable of interest is SBP, systolic blood pressure. Then go to the data menu, click on data analysis. Then you select ANOVA single factor. Here factor means only one factor variable is here. Factor variable means categorical variable. So here we have only one categorical variable, that is place. River bank, rural and urban. There are three factors are there, or three categories are there. That's why one single factor. If there is another factor, then it is called ANOVA two factor. So here ANOVA single factor or one factor. Then click on OK. Then input range, you select the whole data range. Input range, then group by columns. Yes, our data set is in group by columns. Then I have to click on levels in the first row, because first row representing the variable names. Then click on output range. After clicking here, immediately you have to click on this blank rectangular box to display or to make the software understand that I want to display my result from this particular blank cell. Okay? Then click on OK to get your result. So this is the ANOVA table or ANOVA analysis. From here, ANOVA single factor. These are the basic summary of descriptive statistics. For river bank, count 36. Sum 4,964, average is 137.889, and then variance is 656.102. Similarly, for rural and urban, these basic statistics information are there, and this is the ANOVA table. Source of variation comes from the groups. So between group means, that means your place. Three different places are there. That is the between groups, and within group means error. This is the error. Now here the variable of the value which we are interested to see, this F calculated value and then this F tabulated value. This is the table value. F critical means table value and this is F calculated value. You can draw the conclusion based on these two values, calculated F value and critical F value, or based on the P value also you can draw the conclusion. So here you can see calculated F value is less than the tabulated F value, that is 3.09. 1.5 is less than 3.09. So we can say that there is no significant difference among the different places of the patients with respect to the systolic blood pressure. These are hypothetical variables. Okay, but this calculated the significant difference, you have to go for pair-wise comparison. That is called post-hoc test. Those post-hoc tests are not available here in Microsoft Excel. But if you are using SPSS or GEMOV, then easily you can perform the post-hoc statistical test. 2K test, Bonferroni test, lot of statistical tests are available, post-hoc tests are available, but those tests are not available in Microsoft Excel. This is the drawback. Otherwise, simple static analysis you can perform it, no problem. Students, you are feeling bored? Huh? You might feel that you can bore, right? Because you people are, at this stage, you people are not interested in research. Your ma'am and teachers can understand what I am talking about. Okay, this is all about the Microsoft Excel. But anything you would like to know more, then please ask me. So these are the statistical analysis available under analysis toolpack. Anything you would like to know from me, then I can show you. Otherwise, we will directly move on to the Java. Because Microsoft Excel is everyone, you can test it or you can practice it based on this data or in your data. Any data set you can take, no problem. So Java is a new software. Let us go there and then learn it. Yes. Chi-square with Excel. Yes, we can do. But we need, for chi-square, we need categorical variable, chi-square test of independence. So here you can say, perform the chi-square test for independence between gender and place. But literally there is no meaning. Gender and place, is there any association between gender and place? No meaning, but I can show you how to perform it. But remember one thing, that to perform chi-square test, we need at least 2 categorical variables. Okay. Let us go to the sheet number 1, where our original data values are there. I select all, then click on OK. So to perform chi-square test, we need table, observed frequency and expected frequency. Okay. So to make that table, you can take the help of this data and filter option, so that you can find it out how many males are there, how many females are there, how many males under rural, how many males under urban, how many males under riverbank. But it will take some time to perform it. But you can do it, no problem. Another way is that you can do it, that is using pivot table. If you click on insert, first let me select the whole data set. Okay? Then go to the insert and then click on pivot table. Then click on OK in a new worksheet. Now look at this. Moment you click on pivot table, the whole worksheet, the new worksheet will behave like a software now. All the variables are available here. This one, ID, gender, age, place, SBP, BDP, all these variables are available here. So say, I want to perform the chi-square between gender and place. Again, I am telling you, literally there is no meaning. But since you want it, so I want to show it. Because in this data set, we have only these 2 categorical variables. But moment I click both the variables appear under rows. So I want this place variable under columns. So what I can do, I can select this one and then drag it to the column box. Now look at this. Row wise we have female and male, and then blank. Why it is blank is coming. Okay, the reason behind is that, let me delete this thing. Let me do it again. Blank should not come. Since I select the whole sheet, okay, now go to the insert pivot table from from pivot table range and then click on OK to get the new worksheet. Let me select gender and place again. Now you see blank option is not coming. Male, female, and then river bank, rural and urban. Now we need the frequency. To get the frequency, you select or click on ID. When you click on ID, then frequency values will be automatically displayed in this particular table. But these are not frequency tables. Total number of respondents we have 99. But the total here we have seen 4,950. Because why? Because these are displaying sum of ID numbers. We need count of ID numbers. So what you have to do, click on this particular box and then you click value field settings. From value field settings, look at this. Instead of sum, you click on count. Instead of sum, you click on count and then click on OK. Then you will see exact frequency values in this particular table. The total 99 respondents here. This is your grand total. Now from this table we can easily calculate the chi-square. So these are your observed frequencies. 15, 20, 11, 21, 16 and 16. These are your observed frequencies. So what you have to do, you write down the observed frequencies here. Observed frequency and here say expected frequency. So first let me write down the observed frequencies. 15, 20, 11, 21, 16, again 16. These are our observed frequency. Now for each and every observed frequency, we have to calculate the expected frequency. The formula for expected frequency is for 15 corresponding to row total into column total, bracket close, divided by grand total, that is 99. Press enter. This is the expected frequency. Marginal row total, that means when you are selecting 15, for 15 marginal row total is 46. For 15 marginal column total is 36. The formula is 46 into 36 divided by 99. Grand total. Similarly for 20, for this one, this time I am going to calculate the expected frequency for 20, this one. So for 20, this one, yes, 46, 36, bracket close, divided by 99. Next, for 11, 46 multiplied by 27, bracket close, divided by grand total, 99. Similarly for 21, 53 into 36, bracket close, divided by 99. For 16, 53 into 36, bracket close, divided by 99. And for last one, 16, 53 into 27, bracket close, divided by 99, grand total. So once you have observed frequency and expected frequency, then manually also you can do, or in case of Excel, there is a formula called chi-test. This one, chi_test. If you are using Microsoft Excel version 2007, then it is chi.test. For later version, it is chi_test. That means chi-square test. Now it needs information for observed frequency and expected frequency. So these are the observed frequency. comma, expected frequency. Bracket close, press enter. Whatever. Okay, this is not chi-square dot test, not chi_underscore test. Chi_sq dot test, actual range, this one, comma, expected range, these are the expected range, bracket close, press enter. This is nothing but the p value from chi-square. If this p value is greater than, less than 0.05, then we will say significant. But here it is greater than. It is greater than. So there is no significant difference between gender and place. So this way you can perform the chi-square test. Observe the expected frequency, you have to calculate it by memory. After that you can do it, no problem. But if you are using SPSS or DemoV, then no need to do this kind of calculations. Automatically from the variable, software can understand which one is categorical, how many categories are there. Automatically software can understand. So it is very easy if you are using DemoV and SPSS. Okay, before going to the DemoV, if you have any question related to data analysis using Microsoft Excel, please ask me. Any question if you have related to Microsoft Excel for data analysis, please ask me based on the dataset available so that I can show you. Online participants, you can put your question in the message box. Do you have any question? Any question? So you all are from nursing students? So I will ask you one basic question. What is the difference between mean and median? What is the difference between mean and median? What is the difference between average and median? And why they are called measures of central tendency? मीन भाग जाएगा सबका. Don't worry. Please tell me answer. If you are wrong, then I am here. I can correct you. No problem. Median element. Anyway, yes. You can tell me. Yes, mean is the average. Then median. Median is the middle value of the data set, which helps you to divide the data exactly equal to two parts. Okay? But mean has a severe drawback. The drawback is called extreme value effect. Whenever in your data set there is an extreme value, it has a tendency to shift it. But there is no tendency of extreme value or no effect of extreme value in the median. You can exactly find out if your intention is to find out the mid value of your data set, then go by median, not mean. Okay, rightly pointed out. Very good. Okay, this is a new software called Jamovi. Okay, so we are gradually moving on to the Jamovi software. It's a free software. It's based on R, but if you learn R, then you have to write down some codes. Okay, to perform the R software, to perform data analysis using R software. But Jamovi is a GUI interface using which, without any writing any code, you can perform data analysis using this particular software. It look like SPSS, but it is not SPSS. Okay, it's a real-time environment. In SPSS, you have to step by step perform the process. Then when you click on OK or to get the result, when you select OK, ultimately result will be displayed. But in case of Jamovi, whatever you are doing or clicking in the left hand side, in the right hand side, analysis will, output will be automatically showing to you. So this is the benefit of this particular software. Now, variable, by default A, B, C, three variables are automatically there. There is no any data under this A, B, C in this particular software. And statistical analysis are available under exploration. You can see under exploration, descriptives, scatter plot and parallel chart you can perform. T-test, you can perform independent sample t-test, paired sample t-test, one sample t-test, then Bayesian independent. All these parametric equivalently you have to perform Bayesian. You can perform Bayesian here under this particular menu. Then under ANOVA, one-way ANOVA, repeated measure ANOVA, ANCOVA, MANCOVA. Then other Bayesian parts and then non-parametric equivalent to ANOVA, non-parametric Krustal-Wallis, and equivalent to two-way ANOVA Friedman, two-way ANOVA test also you can perform. Under regression, these are the analysis available. Frequencies, you can perform different statistical tests as well as frequency table. Then from factor, reliability analysis, principal component analysis, exploratory factor analysis, and then confirmatory factor analysis. These are you can perform. From linear model, higher level of factorial design you can perform. Then JJ state plot you can perform. You can see histogram, scatter plot, correlation matrix, box, Violin plots, you can see dot chart. So these are the options are available in your hand. Then under measure, proportion test, dichotomous models are available. Lot of options are available. Under SCM you can perform path analysis. Then using snow cluster, I think yes, you can perform clustering. PCA plot and clustering you can get it under snow cluster. Okay, but let me show you how to bring the data from Microsoft Excel using Jamovi first. So this is the main part. So generally whenever we collect the data, we store the data in Microsoft Excel. So it is very easy for us when we can bring the data or import the data from a particular software to Microsoft Excel. It is very easy for us. So to bring in this particular data set, go to the here you can see three equal signs, three signs here, three straight lines like Mahadev ke iske hota hai na 3 line hoega. Then special import, browse. So my data set is in download, Royal Global data set. Click on open. But A, B, C, these are blank, so I can select these three variables and then delete it. So that my variables start from ID, gender, age, place. Let us see whether all the variables are coming or not. Yes, all these variables are coming here in the Jamovi. This is the step. Simply you can bring the data Excel file to this Jamovi software. Now you see ID, it's a scale variable. Okay, but it's not a scale variable. Gender, yes, it's look like it is a string variable. Age is not a string variable, but I would have to change. It is a continuous variable. So how to change it? If you click 2 times in a particular variable, then you can see the properties of the variable in this particular software. So here, variable name is age, measure type is nominal, data change is changed to continuous. Because age is in continuous. 60 years, 65 years like this. Then you have to click here to hide it. Now it becomes scale variable or continuous variable. Place, it is okay, it is a string variable. Then SBP, DBP, diastolic blood pressure. Again it is a continuous variable, but it's look like nominal. So double click here, then you change the category of the variable. Continuous. Measure type is continuous, then hide it. Now everything is okay. Only these two variables, gender and place, are categorical, others are continuous variable. Now if I click here, I can see these three options: nominal, ordinal and continuous. Or ID is there. Okay, let us change the ID here. So it is not continuous, it is ID. So that software can understand. Now do you know the difference between nominal, ordinal, continuous? What are the four primary measures of scale? There are four primary measures of scale: nominal, ordinal, interval and ratio scale. So any variable you choose, it will fall any of these four categories. So nominal means you are assigning some numbers to identify the categories. Here we have gender, male and female. If I assign male equal to 1, female equal to 2 for analysis purpose, it does not mean that female is getting 2, female is more better than the male. No, it does not mean. It is just I am assigning some numbers to identify the categories. So there are some specific variables, say gender, religion. You can assign some numbers, but you cannot compare them. Which one is better? In that case, it is called nominal variable. But educational qualification, you can assign some numbers. HSLC equal to 1, HS2, graduate 3, postgraduate 4. Then these are called ordinal numbers. Some national orders are exist. Because a person having educational qualification PG, his or her knowledge is far better than the person having educational qualification HSLC. When national orders are exist, then it is called ordinal variable. Otherwise, it is nominal variable. Now, in SPSS or JMOB, both these software, interval and ratio considered as a continuous. In SPSS, it is called a scale. In JMOB, it is called continuous. Same thing. You cannot differentiate both these variables. Only difference is that in case of interval scale, null point is not fixed. That means 0 point is not fixed. It has some meaning. So interval scale example is, or variable example is temperature. 0 degree temperature, temperature can go beyond 0. That is called interval scale. Okay? So, but ratio scale variables are started from 0. Age starts from 0. Number of passengers, number of students, everything starts from 0. The variable which starts from 0, then it is called ratio scale. Okay, now our data set is ready. So let us perform some analysis. Exploration say descriptive. I want to perform the descriptive based on this data. Now descriptives, look at this. Moment I click on descriptives, in the right hand side, output window is displayed automatically. Okay. Now anything you want to choose here. Say descriptive statistics we need for age. Look at it. The values for age automatically coming up in the output window. Next time we need SBP, systolic blood pressure. Values are already. Then I include DBP, total serum cholesterol, weight, height, and then BMI. All the values are present. It's a real-time output you can see using JMOB. Okay. So what are the descriptive statistics we are getting here? N number of observations. If there is any missing observation, you can see here all are 0, mean values, median values, standard deviation, minimum, and then maximum. Anything you want to know more, then look at this. Under statistics, it is usually hidden. If you click here, then you can see other options. If you need more, click, then more will be displayed here. If you need some values, then click here. If you need variance, click here. If you need interquartile range, then click here. Moment you click, in the right hand side you will see the result. Now if you need any plots, these are the plots available. If you want to see the box plot for any variable or for all the variables, look at this. Since we have selected all the variables, the box plot will be drawn for all the variables separately. For age, SBP, DBP, then total serum cholesterol, weight, height, and last one is weight. So any plot you can choose here. If you need histogram, select histogram. If you want to see the violin plot, you will see the violin plot. Violin with the box plot. For each and every variable, you will see the violin. So this way you can perform the descriptive statistics or graphical representation of the data using Gemobi. Okay, since here one variable is categorical, that is our gender. We perform the Z test in case of SPSS. As we know that for large sample we can perform T test also. So here let us perform independent sample T test based on that variable. By considering any one continuous variable, we can perform independent sample T test. Okay. So here gender is the grouping variable. Because we need only two categorical variables. So gender I will enter under the grouping variable. Now which continuous variable you want to take? To find out the significant difference between male and female. Weight. Okay, let us take weight and then bring it to the dependent variable. So this is the result, independent sample T test. Statistics, value is 0.728, degrees of freedom 97, p value is 0.436. It is giving p value, not table value. It is giving p value only. So all the variables you can take, no problem. You can take age, it will come under weight. If you can take SBP, it will come under age. For each and every variable you can perform independent sample T test. But we need at least two categories to perform one grouping variable. Here our grouping variable is gender. Then other options are there. As we all know that T test can be performed when the variable of interest or continuous is normal in nature. If it is normal, then only we can perform T test. Otherwise, if normality assumption should be whole by the continuous data. If it is not normal, then we can go for non-parametric test. Equivalent independent sample T test, there is a man with me U test, which we can perform. But to check the normality, look at this. Normality test is there. Look at this. Out of all these variables that we choose, weight, age, SBP and TSC, P values are significant for weight and SBP. That means low p value suggests a violation of the assumption of normality. That means weight and SBP, these two values are not following the normal distribution. But age and total serum cholesterol TSC, these two are following the normal distribution. So you can go for independent sample T test based on age and TSC. But for weight and SBP, you cannot go for independent sample T test because data values are not showing the normal you can simply from here, you can select the main Whitney U test. In that case, what you can do, since weight is not following the normal distribution, so let me bring out age and total serum cholesterol. Yes. For these two variables, I can go for main Whitney U test. So this is the result for main Whitney U test. Or you can go for QQ plot also. Graphical representation of the normality test. Look at this. This theoretical line, QQ plot means quantile plot. This theoretical line actually representing the theoretical distribution, and the dots are representing your observed data. So here theoretical line on that straight line is representing the normal distribution, but your data not exactly falls on the straight line. So that's why your weight and SBP is not following the normality assumption. But if you check the normality assumption of the other two variables, that means age and PSC, then you will see most of the values are false in the straight line. Let me show you. Look at this. Almost all the values are false in the straight line. That's why software is showing you that age and PSC data following the normal distribution. So normality assumptions you can check with the help of Shapiro-Wilk test or QQ plot, PP plot, or there is another test called Anderson-Darling test or Kolmogorov-Smirnov test. These are the tests you can perform to check the normality of your data. Now let us perform ANOVA, one-way ANOVA. Since we performed it using Microsoft Excel, so let us see how to perform ANOVA using Jamovi software. In case of Jamovi, you no need to separate the variable for rural and urban, because this software can understand that there are three categories. So let us click on one-way ANOVA. So from here, from the left hand side, place is the only variable where we have three categories. So we bring it into the right hand side grouping variable box. That is place. And then any variable you can take. Let us take this one, PSC. So this is the one-way ANOVA output. It is simply showing you the F value, then degrees of freedom 1 and degrees of freedom 2, then simply P value. It is not showing you the any post hoc test. But this P value, based on this P value, we can decide whether we should go for pairwise comparison or not. Since these P value is greater than 0.05. If this P value would have been less than 0.05, then we can go for the post hoc test. If it is not less than 0.05, there is no point of going post hoc test. Because if you go post hoc test, you will see that none of the pairs are found to be significant. You can check it. Let us click on post hoc. And from here, you can select the key. You can check it. Riverbank versus rural, it is 0.998. Riverbank versus urban, it is 0.399. And another one is urban versus rural, 0.430. None of the pairs are found to be significant. That's why whole ANOVA table is showing you the non-significant result. If any of the pairs would have been found to be significant, then only one pair, then your ANOVA table will show you the significant result. So when ANOVA is found to be significant, don't conclude it that okay, ANOVA is found to be significant, so there is a significant difference among the tests. No, don't go by that kind of conclusion. When ANOVA is found to be significant, go for pairwise comparison to see actually which pairs are found to be significant. It does not mean that ANOVA is significant, all the pairs are significant. No, it does not mean. There might be 2 or 3 pairs are significant, others are not. So you have to find out those significant pairs by performing post hoc test. perform first correlation matrix, then we will perform regression analysis. So before performing correlation and regression using Jamovi, if you have any question, please ask me, online and offline participants. If you have any question or any doubts, see, I am giving you the options to ask you the questions. बाद में मत बोलना कि सामने क्वेश्चन पूछने के लिए मौका ही नहीं दिया. Students, if you have any question, मैंने तो एक पूछ लिया, बदले में एक तो पूछो. Both one is correct. You can interpret the result based on the calculated and tabulated. You can interpret the result based on the p-value. But interpretation is little bit different. If calculated value is less than the table value, then it is not significant. But in case of p-value, if p-value is less than 0.05, then it is significant. P-value should be greater than 0.05, but calculated value should be less than tabulated value. No. Is there any marker? Traditional way, if calculated value of chi-square, not only chi-square, it is true for all the statistical tests. It may be t, it may be f, it may be z, whatever it is. If calculated value of chi-square is less than tabulated value of chi-square, then we say not significant. But in case of p-value, it is greater than, it should be greater than 0.05. There is no such situation that suppose you are performing any test, chi-square test, one software is showing this result and another software is showing this result. No. If this one is true, calculated value of chi-square is less than tabulated value of chi-square, then p-value must be greater than 0.05. Software will show the same result. ऐसा नहीं होगा कि ये वाला दिखा है फिर p-value ये दिखा है, नहीं होगा. But interpretation of based on p-value is little bit different than the traditional way of interpreting the result. For continuous data, normal distribution is continuous. For continuous data, you can check the normality of your data. Normality, yes. So these are whatever the variables we have. Continuous variable we have age, SBP, DBP, TST, weight, height, and BMI. All are continuous. So we can go for normality test. But for gender and place, we cannot go for normality test. Okay, any more question? This is boxing data. Any question from online participants? What is the full form of RASCH person? So Kharkar sir, can you please tell me what is the full form of RASCH person parameter? Okay, let us go to the bivariate data analysis. So as we all know that measures of central tendency, measures of dispersion, these are univariate data analysis. That means one variable at a time you can consider and you can go for the analysis. These are called univariate data analysis. So at a time when we consider two variables, more than one variable, then it is called bivariate data analysis. So for correlation and regression, we need at least two variables so that we can perform those analyses. If there are more than two variables, 3, 4, 5, then it is called multivariate data analysis. Okay? So here, first let us go for performing correlation analysis. Correlation we can perform when we are interested to find out the relationship between the variables. Okay? And the correlation we all know that lies between -1 and 1. That R value lies between -1 and 1. So for correlation also, it depends upon mean and standard deviation every time. If you remember the formula, in the numerator part covariance, in the denominator part standard deviation. So for correlation and regression also, we need that mean and standard deviation. So for continuous variable only, we can perform the correlation. So let us perform the correlation matrix for all these continuous variables. So look at the correlation matrix here. So age versus age, there is no correlation value. Okay? That means it is exactly 1. Then age versus SBP, correlation is found to be negative. Age versus DBP, correlation is very less, 0.005. Age versus TSC, 0.051. Age versus weight, again negative. Age versus height, 0.075. Age versus BMI index, 0.187. But age versus height, age versus weight, it should be positive. It should not be negative. Here it is coming negative. Maybe these are hypothetical data. That's why. But when age increases, we all know that weight should be also increases. So it should be positive. But here it is comes out to be negative. So this way you can perform correlation analysis, and these p values are actually showing you the significance of this particular correlation. Look at this. It is age versus SBP. This is the value of correlation, and below this you have a p value. So this p value is showing you the significance of this particular correlation result. That means correlation test value. So if it is significant, then you can interpret it. If it is not significant, you cannot interpret it. Because correlation result having any meaning if it is found to be significant. If it is not significant, there is no meaning of interpreting the result. Okay? Because this is just a numerical measure. Theoretically, they may not be related. Okay? But since it is a numerical measure, it may show you the significant result sometimes. For example, in a particular book, I forgot the writer, they say that correlation can be also a nonsense correlation. For example, if you put the data rainfall in Japan and fish production in India, sometimes it might show you the significant result. But it does not mean that there is a significance between rainfall and fish production in India. So you have to be very careful when you perform the correlation. There should be theoretically related both these variables. Then only you can perform it. If there is no theoretical relationship, by simply putting the data, don't try to go for the correlation analysis. Then let us perform linear regression. Now, to perform linear regression, there is a concept of dependent and independent variable. The variable that we have considered here, forget about gender and place. Other than gender and place, an ID, age, SBP, DBP, total TSC, weight, height, and BMI. Out of all these variables, which one we can consider as a dependent variable? Any one variable you can choose as a dependent variable, but which one we can choose as a dependent variable? I'll answer these questions later. So students, which one we can consider as a dependent variable? Fourth year students especially. Only fourth year. Yes, BMI value we can consider as a dependent variable. Other variables we can consider as a independent variable. Okay, let us BMI put it into the dependent variable box. And then age as a covariate, SBP as a covariate, DBP, total serum control, cholesterol, weight, and height. Let us put all these variables as an independent variable and BMI as a dependent variable. Look at the result. The model R-square value is showing you only 13.6% variation in the dependent variable. So though we are considering all these variables as an independent variable or as a contributing variable to the BMI, body mass index, but it is giving or showing you only 13.6% variation in the BMI result. So it is very less. More the value of R-square, better is the regression result. But here R-square value is very low, 0.136. If you multiply it by 100, then it is only 13.6. So since result is R-square value is not good, and if you see the model coefficient values, model coefficients also not found to be significant. Okay, only one is found to be significant. Total serum cholesterol is found to be significant. Look at this. It is 0.039, which is less than 0.05. So out of all these independent variables, age, SBP, DBP, total serum control, weight and height, only one is found to be significant, that is total serum cholesterol. Others are not found to be significant to the BMI, contributing to the BMI body mass index. These are hypothetical values, don't think that it is a real, but this is the way you can interpret the result. Now, one assumption is that in case of regression analysis, your dependent variable should be normally distributed. So look at this here, assumption check in this software, GemoB. So from here, you can perform the normality test. So normality tests say that it is normal. And you can perform the QQ plot of residuals, and residual plots also you can check. So QQ plot of residuals also showing the normal distribution. That means error should follows normal distribution, mean, zero, variance, sigma square. Those theory actually holds here. And then residual plots should be look like a big zero. That means there is no information exists like this. So it is look like a big zero. But if it is not zero, if residual plots is showing any kind of trend, that means assumptions are not whole. So it is good here that it is showing a big zero type. That means there is no information exists in the residual. It should be look like a big zero. let us quickly see the one thing, that is how to create biplot or PCA plot. Okay, biplot, by considering all the factors, how to create the biplot. Principal component analysis, biplot, how to create it. It is known as PCA plot. PCA plot. Here let us consider only those continuous variables to create the PCA plot. Age, SBP, DBP, total serum cholesterol, weight, height, and then BMI. By using this, then analysis. If you want to find out the biplot, look at this. This is the PCA biplot using principal component analysis. These are the high statistical modeling or high statistical analysis. PCA cluster analysis you can very easily perform without writing any code using Zamovi software. This is called PCA biplot, representing only two dimensions, PCA 1 and PCA 2. That means 21.9 and 70. Total 718. Only 38% variation is showing, but by using PCA 1 and PCA 2, the variation should be more. But if you want to see again the individual variable plot, individual plot, here also you can see the individual plots. This is called individual plot. Based on PCA, this is called biplot. So this kind of analysis very easily you can perform using Zamovi software for your research purpose. So anything you would like to know more than this or less than this, whatever it is? Any question? Offline participant? Otherwise, I will go to the questions to the online participants. No question? Then let us go to the question of online participants. The first question by Kharonkar. Sir, how can we calculate RAS? That means is a psychometric model to analyze categorical data. But it is very difficult for me to. I don't know what is psychometric model to analyze categorical data especially. But if you want to convert it into the Z values, I can show you how to convert a particular variable value into the Z value. That I can show you. But how to convert it to the categorical data to the Z value, I don't know, truly speaking. And then, sir, is there any method of calculating p-value manually? Yes, manually p-value calculation is possible, but it will take a lot of time. You have to find out the distribution. But it is very easy for you to go for, if in Google, if you type it, the question asked by Shrutimani Kakoti, in Google, if you type the p-value calculator, then you will get lot of p-value calculators. Okay, lot of p-value calculators you will find it out based on the data. So in your case, you have to put the degrees of freedom and then mean value or standard deviation value, whatever it is required. Then it will give you the p-value. But don't go by manually. Manually, it will take lot of time. Okay, let me show to Kharonkar sir how to transform the any particular variable value to the Z value. Okay, let us take this variable BMI. So I want to convert this BMI particular variable to the Z value. Z BMI suppose, okay? So let me write BMI underscore z. Then the formula is you take this particular value minus the mean of the entire data set. Close the bracket, then divide it by standard deviation of entire data set. This is your range. Control V. But to fix this particular range, you can use the dollar sign, so that this range cannot be changed when you drag it down. So these are the Z values based on the BMI. As we all know, the standard Z distribution or normal distribution range is also minus. Range is minus infinity to infinity, Z range, but the standard one is 0 to 1. This is the conversion of BMI value to the Z values, which I named as BMI Z value. Some values are negative, some values are positive. So this is the way you can convert any particular value, that is any particular value from that particular data set minus mean value divided by standard deviation. The value minus mean divided by standard deviation, this is the formula to convert the Z value. Is it okay, sir? Okay, thank you. Any more question? We have only 5 minutes. If you have any question, please ask me quickly. Eta question কিন্তু student of লাগিব নহলে মোৰ ৰুমৰ পৰা ওলাই নাযাওঁ think about it what question you want to ask me think about it and discuss among yourself Last question. Please ask me. Yes. The importance of minimize the suppose there is a outlier in the data set. One is the between the lower side and the upper side. Minimize the effect of outlier in the data set. For each and every thing, not only one thing or one thing. For each and every thing. No. Only for continuous data you should go for that. question, please. कौन पूछेगा? Have you seen the movie Munna Bhai MBBS? वो तो पूछते हैं ना, अरे पूछना, please. One question. Yes, it may be related to your study, it may be related to your project, anything. How to? How to calculate the sample size? Very good question. ये अगर मैं नहीं पूछता तो वो नहीं पूछता, पता है? But this is a very important question. How to calculate the sample size? So there are a lot of formulas for infinite sample, for finite sample, based on the population. Lot of formulas are there. If you want to know all these formulas, then go by the book Research Methodology written by C.R. Kothari. Research Methodology written by C.R. Kothari. In that book, all the formulas are given for sample size calculator. But quickly, if you want to find it out the sample size, then look at this. There is a sample size calculator. It is called sample size determination. Calculator.net. This one, lot of sample size calculators are available. But look at this first one, proportion. Proportion one, you can consider 95% confident. Population size you have to give. So tell me your population size. 10,000, 12,000, whatever it is. Tell me. Only 170 population size. Okay. Population size. Population is bigger. Sample is a part of the population. You are talking about for sample size or population size? 20,000. Okay, let us go by 17,000. Okay, population size is 17,000. Expected proportion 0.5. Margin of error 5%. Then click on calculate. It is 377. That is the optimal sample size. 377 you have to collect it. After collecting the sample, the data set that I shown you, that is after collecting the sample. You have to enter the data using Microsoft Excel or Google Form you can use, distribute it, then directly you can download it, so that data is in Microsoft Excel format. That's what I am showing you. When you have a data set in Microsoft Excel format, how to calculate it using Excel and how to calculate it using Zemobi or other software. This is the purpose of this particular workshop. Descriptive studies, you can, fourth year students, for descriptive statistics, you can calculate mean, you can calculate median, go by mean values of different graphical representation, then standard deviation you can show, then standard error you can report it, okay. The mean plus minus SD can give you the actual range. So whenever you are reporting, say average value of, whatever it is, say average value of, or say here, based on this data set, average value of EMI for rural people is this one. That is the average value, only one value. But that one value is not sufficient in case of research purpose. Instead of giving a point estimation, we give the interval estimation. You can, instead of giving one average value, you give a range. That range you will get it mean plus minus SD. You calculate the standard deviation, mean minus SD one value, mean plus SD another value. You can say that for rural people, BMI value lies between this value and this value. That is the actual interpretation. You may interpret it that the average value will be this, but another person is performing the similar research, but he or she will not get the same result, that point estimation value. So instead of giving the point estimation value, we give a range. So that other person, when he or she perform the research, if his or her results falls into your category or your range, that means your analysis is perfect. And your citation, your paper citation will be more in future. The people love to cite when results are found to be similar with the other research paper. In the conclusion and discussion section, we cite it generally. So that's what actually your citation increases. If your results are more accurate or if you express it more explicitly, then people actually found very easy to cite your research paper. Another thing, correlation, regression you can perform. These are the basic statistics. No need to go for the higher level of modeling, PCA, cluster, no need to go for this level. Until and unless you are doing PhD. Pause. Okay. What sensor you will get from especially logistic regression. When you are dependent variables category can be set, then you can get the odds ratio. Odds ratio will help you to calculate the probability. What is the chance of having that particular category? For multivariate, it is called multinomial logistic regression. For multivariate, if in a dependent variable only one category, two categories, 0 or 1, yes or no, that, then it is called binary logistic regression. If there are more than two categories, 0, 1, 2, 3 like this, more than two categories, then it is called multinomial logistic regression. Don't go by binary, then multinomial. In that case, odds ratio calculation is a little bit different than binary. Okay, then any more questions? If there is no question, then I can stop. Okay, thank you.
What an insightful session it was, isn't it? Okay, thank you, sir, so much for enlightening us regarding the various statistical software useful in data analysis, and I'm sure with application of all these methods, all of us will be greatly benefited. Thank you so much, sir. With this, we have come to the end of today's session. I hope all of you had a good time with all the new learning. We will meet again tomorrow at the same time for the final day. Thank you so much. Have a great day ahead.